Have you ever stopped to look at the sky and wonder, why doesn't that fall? Because a regular cloud, the kind you see on a sunny day, can hold more than 300 tons of water floating right above your head. That's the weight of 50 elephants, suspended in midair, directly over you. So how does that work? And what happens when it doesn't? Before we calculate the weight, we need to understand what a cloud is actually made of, because the answer is going to be a lot less obvious than you'd expect. Clouds aren't smoke. They aren't gas. They're real water, just in droplets so tiny they basically bump into air molecules and stay suspended, the same way a styrofoam ball floats in a stream of wind. The most common cloud you see out there, those white, fluffy ones on a beautiful day, is what we call a cumulus. The word comes from Latin and means pile. That makes sense when you look at them. They stack upward from the bottom, and the higher they stack, the more you're going to want an umbrella. But we'll get to that in a moment. To calculate the weight of a cloud, we need two things: how much space it takes up and how much water there is per cubic meter of that space. The second part is what physicists call liquid water density. Researchers have already measured this for cumulus clouds. It's approximately 0.3 grams per cubic meter. 0.3 grams per cubic meter. That's less than a grain of sand. It sounds absurd to say that weighs anything at all. But then comes the first part, the volume. An average-sized cloud is about 1 kilometer wide and 1 kilometer tall. When you do the math, 1,000 meters times 1,000 meters times 1,000 meters, you get 1 billion cubic meters. Now multiply that billion by 0.3 grams. 300 tons of water. Something that looks like cotton candy carries the weight of 50 adult African elephants. But then why doesn't it just drop? The answer is, it does, just too slowly for you to notice. Each droplet falls at a terminal velocity of roughly 1 centimeter per second. At the same time, warm air currents rise and push those droplets back up. It's a constant balance. The cloud looks still, but it's a system in motion the entire time. And when that balance breaks, when there's too much water for the air currents to hold up, the droplets merge, grow too heavy, and then rain. Rain isn't the cloud breaking apart. It's the cloud releasing the weight it built up. Now, what if I told you the universe is full of clouds? Only clouds on a scale that literally doesn't fit inside the human brain. There are structures called nebulae, the largest clouds that exist, made not of water, but of hydrogen, helium, and dust. Some are light years across. The Orion Nebula, which you can actually see with the naked eye at night, is about 24 light years in diameter. The density of a nebula is so low that you could literally put your hand through one and feel nothing. You could see your hand perfectly clearly inside the largest cloud in the universe. Compare that to the air you're breathing right now. It has 10 to the power of 19 molecules per cubic centimeter. A nebula has maybe 100. And you know what the most absurd part of all this is? It's from inside these nearly empty clouds that stars are born. The entire solar system, the sun, the earth, you, most likely formed from a nebula that collapsed on itself 4.6 billion years ago. You are literally made of cloud. Just a cloud much, much older than anything you'll ever see in the sky. The next time you look up on a gray, overcast day and think, ugh, what miserable weather. Remember, you're looking at 300 tons of water in dynamic equilibrium on a planet that exists because of a cloud that died billions of years ago. I think that deserves a second look.